The first video today has absolutely nothing to do with Taylor series. This is a small little topic that I've kind of ignored until now, but I want to get it out of the way. All right, we're going to talk about the average value of a function. It's a very popular question in the AP exam, by the way. I'm going to start by asking some really easy questions. First, an object moves at 9 miles per hour for 2 hours. How far did it move? No tricks. Distance is equal to rate times time. And so it's 9 miles per hour times 2 hours. 9 miles per hour times 2 hours. Remember, the hours cancel out, and we get to 18 miles. No tricks. What about an object moves 30 feet in 6 minutes? What was its average velocity? Well, again, no tricks here. Average velocity or speed or rate, a lot of synonyms here, is equal to distance divided by time. If d equals rt, then r equals d over t. Well, if you drive 30 feet in 6 minutes, you are moving at 5 feet per minute. Again, no tricks. Easy idea. But the important word here is average. The average velocity. Well, as we've seen throughout the year, what makes it a little bit more complicated is if the velocity is not constant, if it's changing. So here, the velocity of a moving object is 12t minus t squared. And what if I wanted to know the average velocity in the first 12 seconds? Well, we just said that the average velocity, or the rate, is distance divided by time. So if I could find the distance traveled in the first 12 seconds and divide it by those 12 seconds, I could get the average velocity. The average velocity is d over t, but we need a way to calculate d. All right, well, how do you figure out how far something has traveled in 12 seconds if all you know is its varying velocity? This brings us back a few months, but we talked about this earlier. That would be the definite integral of the velocity. The distance traveled is the definite integral of the velocity from A to B. Or more generally speaking, any function, let's say the distance from A to B. Any function, this is the fundamental theorem, any function, the difference between f of b and f of a would be equal to the definite integral from a to b of the rate of change of f. Getting a little off track here. Thinking back just the simple example here. We want the average velocity. We need to find the distance traveled. To calculate the distance traveled, we just take the definite integral. Well, if we generalize that and say, all right, forget about average velocity for a second, just any average value, we can come up to the same thing. Where if I ever want to find the average value of any function, it would be equal to the definite integral from a to b of that function divided by b minus a. So I'll go back to what I had written before. If we remember, if we the average value of any function, well, no, I'm just going to skip that. We'll come back to it later. Let's look at a couple of examples. This is a big formula. It's nice and simple, but it's important to us. So let's look at a couple of examples of it. This first one, number 20. The average value of cosine on the interval from 3 to 5. Well, the average value is the definite integral from negative 3 to 5 of the cosine of x in respect to x. The average value of a function is its own definite integral divided by the distance traveled, the length of the interval. So this would be 5 minus negative 3. So hopefully we can already see that we need an 8 in the denominator. And so the numerator would be the antiderivative of cosine of x, evaluated from negative 3 to 5 over 8. and that would be the sine of 5 minus negative sine of 3 over 8. So that's our answer. Looking at the next one, for any differentiable function, they tell us f of 1 equals 2 and f of 3 equals 7. And so this question is all about understanding the difference between the average rate of change and the average value. Those are two very, very different things. The average rate of change, we've been talking about this since like the second week of school. That's also the difference quotient, the slope of the secant line. That is just f of 3 minus f of 1 over 3 minus 1, which in this case would be 5 over 2. That's the average rate of change. That is very, very different from the average value. The average value of f, which is the definite integral from negative 3 to 5. I'm sorry, those were the numbers from the last example. In this case, it's the definite integral from 1 to 3 of f of x dx divided by 3 minus 1. Now, unfortunately, I have no idea what the definite integral from 1 to 3 of f of x dx is because I don't know anything about the antiderivative of f. So I have no idea if 2 is correct. 1 was. I don't know if 2 is. And then I want you to notice the average value of f prime is the same thing as the average rate of change. Remember, f prime is the rate of change, instantaneous rate of change. So the average of all the instantaneous rates of change would be the average rate of change. So those two things are the same thing. So choices 1 and 3 both have to be correct. Okay, I'll leave these on screen so you can kind of see them and try them on your own. For that last one, just note, you can do it in one of two ways. It asks you for the average rate of change of y. The average rate of change, you could use the formula I just mentioned for average rate of change, this guy up here, or you could find the average value of the rate of change. So you could either find the average value of 1 over x on the interval from 1 to 4, or you could find out what y is using the antiderivative, solving the differential equation, and then find its average rate of change on the interval from 1 to 4. You would get the same answer either way.